So this is the second half of the overview of the basic features. And what we're going to do here is we're going to talk about applying the basic completable futures features to do a big fraction multiplication program. This is a variant of things that you've seen before. If you recall, what big fractions do is they let you do arbitrary precision arithmetic on large fractions. Why you'd ever want to do that is somewhat a mystery to me, but it's cool, and it demonstrates some of the features that are useful with completable futures. And then, of course, we'll also talk about the downsides with the basic features of completable futures, which, of course, is there to motivate why we would be doing the more advanced features, which we'll cover next. So if you recall, what is a big fraction? It allows this arbitrary precision fraction using so-called big integers for the numerator and denominator. Big integers are a Java class in the Java class library that lets you do arbitrary precision arithmetic. And they take a while to run, which is why we're going to use the completable futures features here, as you'll see in a second. There's various factory methods in the big fraction class that allow you to create so-called reduced fractions. So if you were to give any of these as the numerator and denominator, the reduced version would be simplified. So 12/24 is 1/2, all the kind of stuff you probably learned in like second or third grade. There's also factory methods for creating so-called non-reduced fractions, and then an API to reduce them later, because reduction takes a little while to run, especially for a really big fraction. There are methods for doing arbitrary precision fraction arithmetic. So if you take 18/4 and multiply it by 2/3, you'll get a result, which in this case is 3. And then there's also a way to create a mixed fraction from a so-called improper fraction. So this is a so-called improper fraction, and this is a mixed fraction, or I guess it's a proper fraction. So 18/4 is 4 1/2. So these are just all the different methods in there. And the key point here is not to become an expert at big fractions. It's to recognize that there's these long-running computations that are going to benefit from concurrent asynchronous operations using the completable futures. So here's kind of what the program looks like. This is the code over here, and this is a diagram kind of showing the interactions between the various parties. So we've got a main thread, a background thread, and a completable future, and I'll kind of highlight what's happening visually as we look at the code. And as usual, that's where you can get the code. So what we're going to do first is we're going to make ourselves an empty future. So you can see this is a future that is not associated with any computation yet. It's just a placeholder that we can use to complete and wait on via join. So here you can see we're making a new completable future. We then go ahead and create a new thread with this lambda expression. We'll look at the lambda expression in a second. The key thing to note is this is what's going to be run by the thread when it starts. When you call start, that causes a new thread to be created, and it'll run in the background. So that's the background thread. When we say start, this computation will start to run, and it'll run in parallel with anything else that's going on, in this case, the main program, the main thread. Here's the actual computation itself. We're going to take big fraction 1, BF1, and big fraction 2, and we're going to go ahead and create the big fractions, and then we're going to multiply BF1 by BF2. So that's going to be a computation. And this could take a fair amount of time to run, especially if you made the fractions big enough. So that's going to be running in the background. Then that computation here, the big thread, the background thread, will be running in parallel with what's going on in the main thread. I don't really show anything else here, but you can imagine we could be prompting the user, we could be waiting for other user input events, we could be doing other computations, whatever, right? It doesn't really matter. It's just taking place in the background. And then at some point, when the background thread is finished, the code calls complete, and that tells the future we're done. It sets the result of the multiplication as the result of the future, such that whenever the main thread calls join, it'll get the result. Now, if this join happens before this computation is finished, we'll block here. If this computation is already finished, then we won't block on the join. So it'll just return, and it'll give us the result back. And as you can see here, we're going to print it out as a mixed string. So that's the way it runs, or that's the way it works. Let's talk about the downsides. The good part about this is it's fairly straightforward to understand this. But the problem is all those limitations we talked about earlier in a couple lessons ago that were limitations with futures are still the limitations with the basic features of completable futures, because they don't really add anything. They add the complete method. They add the join method that doesn't have checked exceptions, right? Those are vanishingly small enhancements that really don't make a big difference. In particular, probably the biggest limitation with this approach is we still have to call join on the main thread, which is going to block and underutilize the processing for all the reasons we talked about before. Blocking, as a general rule, is a bad thing because you don't know how long you're going to have to wait. And even putting a timeout in here to bound the amount of time we wait, also not really desirable in a lot of ways. So those are the problems with this approach. Therefore, what we need is something more advanced. And that's what we're going to talk about next, which are the other features of completable future, the factory methods, the arbitrary arity methods, the exception methods, and by far the most important and numerous of these things, the completion stage methods. So those will be the things we're going to talk about next.